All right, a new season here. We got spring storm to forecast. And with a new season comes a new map because there's not much to see currently with this forecast here. So here we have a global infrared. Infrared is a fancy word for heat. I'll explain that in a minute. But if you notice here, there's some cool middle school demos you could do with this. I know a lot of people have been using these videos in middle and elementary school. Take a round object, soccer ball or whatever. I got an apple here, and it's on my desk, right? And if we kind of just pretend this is Earth and we rotate it, okay, the amount of distance that you'd have to go to rotate at the equator is much greater than the distance you'd have to go to rotate at the poles. Look, like it's just from here to here, a small distance. Yet at the equator, it's a great distance. Yet the whole apple will rotate in a day. The Earth rotates in a day, right? 24 hours. And so at the equator, there are many thousands of miles that it will rotate in 24 hours. Yet at the poles, there are not those same thousands of miles. So what does this mean? It means that we have a greater rotational velocity at the equator. The planet is actually moved per hour, the miles per hour that the planet is rotating at the equator is faster than at the North or South Pole. And so this creates an imbalance in speed, and things that are not attached to the ground therefore will lag behind. And so if you look at the equator here, it looks like the atmosphere almost has like a canoe paddle that goes through it, or like a finger that's been dragged across it. And just like if you were to take a canoe paddle through water or a finger through water, at the place that you would drag it through, above or below that, you would get these eddies. These are the storms, the spinning storms that we see in the mid-latitudes of the northern and southern hemispheres. So it's kind of cool to think about the atmosphere as a fluid moving faster in some locations and slower in others. That imbalance between fast-moving and slow-moving creates the eddies that you would see just the same way as if you were to drag your finger through water. All right, so new map. What's going on with this spring storm? All right, there's a new map because there's like nothing to see on the radar. I mean, barely anything to see on the radar. So this is an infrared map. And infrared is a fancy word for heat. It's just a wavelength of radiation that means heat. And this is going to show up, and this is going to show up because these clouds are really cold. They're really high in the atmosphere where you're going to get really cold clouds. And so we have this system here and this system here with tons of clouds. So these are our two systems. Down here, we've got a wet and warm system for reasons I've talked about in the past. Up here, we've got a cold and dry system. Wet and warm is low density. Low density rises. Cold and dry, this one up here, is high density. High density sinks. So these two storms are going to stack. We're going to have wet, warm up here, precipitating through cold and dry. When you get wet and warm stuff moving through cold, dry stuff, right off the bat, the cold is going to drop the temperature, so we could see rain turning into frozen rain or snow. But also, wet to dry is going to lead to evaporation. Evaporation is a cooling process. And so we've got two things in this bottom storm. The fact that it's cold and that it's dry are going to lend towards decreasing the temperature of whatever falls from this upper storm through this lower storm. So we're going to see a stacking with this warm storm on top of this cold storm on the Northeast. We've seen this before, and this is not super common, but pretty typical in these late season kind of storms. So what does it mean for us, and why are there these forecasts? This one's difficult to forecast because it's like these storms aren't even really developed very much yet. However, this one down here, man, the precip forecasts for this are intense. Like for us in central kind of New York, we're looking at like an inch or so of precip. But remember, precip is measured in liquid rain, liquid water. And so 1 inch of liquid water could be a foot of of snow. It all depends on the temperature. It's mid-20s outside right now. That could lend to some fluffy snow. So how much is that snow going to fluff up? Whatever. Also, the other thing is like this has that storm tracking kind of over southern New York, Long Island. I mean, man, just a slight deviation north, and we could be in one of these bands of heavy, up to 4 or 5 inches of precip. That could yield a lot of snow. So I think right now it's reasonable. I mean, a storm's going to hit us this weekend. One of these storms is going to hit us this weekend, and it's reasonable to think that we might get a fair amount of precip out of it. And then when you compound that with the fact that this storm down here is not that warm, I mean, it's like mid-50s, and we have super cold. I mean, we're talking in between 10 and 20 degree air up here, pretty cold air up here, that storm is going to rise over. I think this is setting the stage for what could likely be um, a late season snowstorm where we could. It seems some outlets are forecasting a foot of snow. Seems like a little bit much, but I mean, you wouldn't catch me saying that that's crazy. So I think like no snow is too little of a forecast. I think over a foot is too much. And the big variable, we'll kind of watch this if you're going to watch anything over the next couple of days or pay attention to anything in the news over the next couple of days, it would be, where is this storm coming up from the Gulf tracking? Is it tracking further north than expected? We're going to get hammered. Is it tracking further south than expected? Probably leave the snowblower in the garage for that one. That's what I got. We'll keep our eye on this one. Hey, stay safe out there, everyone.